Hey, how's it going everyone? Brian here with another Java game programming tutorial. So the last time we left off, we gave our enemies health. So now if we shoot them enough times, they will disappear / die. But you'll see our enemies, or our towers, are still shooting the ground where they last were, where the enemy last was. So what we're going to do this time is implement a basic kind of targeting algorithm. And we're going to be switching this up later because I feel like different towers will have different algorithms that they use to find enemies and stuff. But for our tower cannon, which is pretty much our basic default tower, we're just going to have it target the closest enemy to it at all times. So first off, what we're going to do is go in our tower cannon class. I think we're going to be modifying all of these classes up here, not the boot, but all of these. And right now our acquire target method is pretty basic. We're just returning the first enemy of each wave. So we want to change that. And we're gonna make an enemy named closest and set it equal to null by default. And at the bottom, we're gonna return closest. So now this method is gonna find the closest enemy to us whenever we want to acquire a target, and then return it back to wherever we called it from, probably our update method or something like that. So in between these two lines is where we're going to do all of our calculations. So let's make a float, closest distance, and let's start it at a big number. Let's start it at something that every other enemy should be smaller than the distance. So let's say like 10,000. All right. And now we're going to say for enemy E in enemy list, so for each of our enemies, is that not what it's called? Oh, it's called enemies, I bet. Alright, so for each of the enemies, instead of our list of enemies here, named enemies, we're going to check some things. Let's make another method first off, and let's say private boolean is in range. And that takes an enemy named E, and range is something that we have not done yet. So we need to actually make a range variable. So for int, let's go ahead and after damage make a range. And in the constructor after damage, add in range. And after we set damage, set our range. Now we can do a range a few different ways. What we'll probably want to do is because the way we're going to do it right now with our calculating is it's going to be based on pixels. So our range might be something crazy like, I don't know, say like 900, and we're checking if there's an enemy within 900 pixels. Eventually, pretty soon here, we'll probably change that to just be like tile lengths. It's like a range of like 5, we multiplied by 64, or whatever size our tile is to get the tile range. It's like easier to imagine, you know, when you're building towers, be like, oh, this tower can hit things 5 tiles away. But for now, we're going to do it based on pixels. So now, is in a range, we're going to get the x distance equals math.absolute e.getx minus x, which is the x position of our tower. Float y distance equals math.absolute e.getY minus y. And we do absolute here because we've done this before actually in this series, and it just returns a positive value. So even if this returns a negative amount, like say like the enemy's x is 100 and ours is 1000, instead of returning negative 900, it'll just turn that into 900. Because we just want to see how many pixels away something is. It doesn't matter if it's negative or positive. Now we can just check if x distance is less than range, as in it's within our range, and y distance is less than range, then return true, otherwise return false. And that is how simple it is to tell if an enemy is within range of our tower. So, what we're going to do now is in our acquire target method, we're going to say if is in range E, then we should actually find the total distance as well. So let's go ahead and make another method, another helper method here. Private float find distance, and we'll take an enemy as well. And we're gonna do the same thing as this right here. We're actually just gonna copy and paste this, and we're gonna return x distance plus y distance. So this is the total number of pixels away that the enemy is from our tower. So if our enemy isn't within range, then we should say, if in range and if find distance enemy is less than closest distance, is that the right amount of parentheses? Then first off, let's put brackets. Closest distance equals find distance E, and closest equals E. So now we're going through every single enemy in the enemy list. We're saying if it's in range at all of our tower, right? Make sure it's within range at all. After that, make sure that, or we're going to check if the distance between this enemy and our tower is less than the previous closest distance. So we start at 10,000 as a distance, which is crazy, right? We're not going to get a 10,000 distance ever. So the very first time we go through this list, no matter what it is, as long as it's within range, it's going to be closer than the closest distance. Say it's like 100 pixels away, right? That'll be the closest one. So we're going to set our closest distance equal to 100 pixels, and we're going to set that enemy to say it's the closest one. But then if we go through this again for the next enemy, and that one's only 50 pixels away, then that'll be a new closest distance because it's less than 100, and that'll be our new closest enemy. So it pretty much just goes through the list and tries to find the closest enemy in that list. And once we do that, I believe we can just return closest. We should make sure, because we have this whole targeted Boolean, I believe. Oh, do we not? We should make that. Private Boolean targeted. That way we know if we actually have a target that we're firing on or if we need to find another one. And we'll set that right here. This dot targeted equals false, because we will not start with a target. And let's comment these out for now, because we're going to change up the way our update method works. So we create a new tower and we start not targeted. We start with no target in mind. Down here, once we find the closest enemy, we're going to check if closest does not equal null, then targeted equals true. Because you'll see up here we start as null, and so the only reason this would ever happen is if we found no enemies within our range. So if every single enemy is outside of our tower's range, then we're still not going to be targeted. Oh wait, yeah. Let's go to our update method now. And we're increasing the time, we're shooting. What we're going to do up here is we're going to say if not targeted, target equals acquire target. Okay? So every time we update, if we're not currently shooting at a target, then we're going to acquire a new target for us to shoot at. And we set targeted equals true at the end of that. So it won't keep running this every time we update, because next time targeted will be true. And then down here, we're shooting, we're updating the projectiles, angle is calculate angle. Okay, there's definitely more stuff we need to do in here, I feel like, but let's go ahead and run it and see what happens. First, we need to go to our player class and include a range in 2 different spots. So 10 is our damage, and for now we'll put the range at, say, like 1,000. And right down here, 1,000. Now, what we need to do first before we test it is we need a way to update our enemy list. And there's a few different ways we can do this, and I think what we're going to do is we're going to revisit this in a future episode, probably pretty soon actually, where we go back and kind of make everything a little bit more efficient. But for now, we're just going to kind of like brute force it in a way. We're just going to do it the quick and dirty way here for now, just to see if our tower algorithm works at all. So the way we're going to do that is we're going to go to our game class, and here we update our grid, or we draw our grid, we update our wave manager and our player. And after we do that, we need to go to our player class. And we're going to make a new method, public void update enemy lists. And that's going to take an array list of type enemy, and I'll just name it new list. And in this, we're going to go for each tower. Yeah, we're gonna clean this up in the future because we could put it in here, but just do this for now. For each tower cannon T inside of our tower list, we need to go to our tower cannon class now and make a method that we're gonna use to update our enemy list. So I'll put it right above the update method here, and I'm gonna name it public void update enemy list, and it takes an array list of type enemy named new list, and we're just going to set enemies equal to new list. Now back to our player class. For each tower cannon inside of our tower list, we're going to t.update enemy list, which is the method we just made, and where we get that list is going to be from our wave manager dot get current wave, so the current wave of enemies that's going, dot get enemy list. So our wave manager has a method called getCurrentWave, because you'll recall wave is its own class over here that is responsible for a certain amount of enemies before it ends. And inside that current wave, we can use this method to get the current list of enemies that are on the screen. So now we're updating our tower constantly, or I guess we will right now in the game class. That's what I was going to do here. Player dot update enemy lists. And wait a second. Player. We don't need a new list here. Yeah, we don't need a new list here. So what we can do... Okay, interesting. So we can just put this... Just copy that. Put a bracket here. Bracket there. And after t.update, just go ahead and put that right there. And we can actually get rid of this method. Alright, that's easier. And get rid of this. Okay, so now every time we update our tower cannons, we're also updating the enemy list to make sure they have the current set of enemies on the screen. Because the set of enemies will change between when the towers were first created and, you know, the future. Because enemies die, enemies spawn, enemies go off the screen. It's constantly changing. So we're trying to kind of like put together a bunch of different things here. Like we're trying to coordinate the wave manager and the game and the player and the cannon class. So I'm going to go ahead and test this now. But I feel like there's a strong chance we might get an error, but we'll see. We will see. Okay, it's looking at our enemy over here, shooting it, that's good. So we're still finding the first enemy, that's good. So what happens is once this enemy dies, we should hopefully not get an error. Alright, well we didn't get an error, but it's still shooting over there, so that's not working. That's pretty much how we had it last time. So let's go ahead and go back to our tower cannon class. And let's see what's going on here. Okay, so what's happening is we're never saying if the enemy dies, then we need to find a new target, right? We're never checking that. So let's go ahead and do that right here. Let's make some space. We're going to say if target equals null or target.isAlive equals false, then targeted equals false. So this will check and it'll say if our target doesn't exist or if it's dead, then we need to find a new target. So let's go ahead and try that. Okay, it looks like it's shooting there and now it finds the next enemy. Awesome. Pretty cool. So now our towers will no longer shoot the dirt infinitely. They immediately go to the next enemy, the next closest one. When the new wave starts, they get the new enemy list. They can actually look at the next wave of enemies happening, which is pretty cool. We got some basic targeting algorithms here. We are checking if the enemy dies and finding the next enemy if that is the case. And that was actually a little bit easier than I thought it was going to be. Sorry if I went a little fast, but, you know, the source code's available on Patreon. And, oh yeah, speaking of which, I said last week there was going to be a vote, and because of the way the Patreon works, and there's like new episodes out and like early episodes for certain people, the vote is going to go live today. So, today as in when I'm recording this episode. I know it's kind of confusing, but just trust me. The vote should have happened previously for most people now. Dealing with time is kind of confusing here because it's like a week delay and stuff. But it should all be taken care of. Hopefully by this point you will have voted, which means that the next episode after this one will be based on that vote. So yeah, thank you for watching, you guys. I hope this all made sense. Make sure to leave a comment if you don't understand something, and I will see you next time.